In this problem, a waste mixture with the following principal organic hazardous constituents, or POHCs, is incinerated, and all chlorine atoms are converted to HCl. Find the total HCl flow rate in kilograms per hour generated during incineration prior to control. So here we are given 3 different POHCs in our waste feed. 1,2-dichloroethane, chloromethane, and benzene. Our objective is to figure out how much HCl is present from the incineration process. So for step 1, let's decide which compounds actually matter. So let's look at the atomic weights that we can find in the reference manual. The 3 that we need are C, H, and Cl, since these are present to some extent in each of the parts of the table. So C is going to be 12 grams per mole, H is going to be 1, and Cl is going to be 35.45. So we can calculate the molecular weights now for each of the feed items that contributes to HCl. This would rule out benzene from the rest of the problem, since there is no Cl in that waste feed. Let's fill in the rest in the existing table below. So we have 12 grams per mole times 2 Cs plus 1 gram per mole of H times 4 of those plus 35.45 grams per mole times 2 for Cl. And that is going to come out to 98.9 grams per mole. Down here, we have 12 times 1 plus 1 times 3, sorry about the parentheses being inconsistent, plus 35.45. And that's going to be equal to 50.45. And then we don't need to calculate the last one. Now, for step 2 and 3, we can convert the feed rates into moles per hour. So for step 2, let's convert the feed to grams per hour. So we're already given it in kilograms, so let's just multiply by 1,000. You could skip writing this out on the exam if you need to save time. And since we have grams per mole and grams per hour, we can now divide column 2 here by column 1.5 and calculate our feed in moles per hour. So 180,000 grams per hour divided by 98.9 grams per mole gives us just about 1819 moles per hour. And doing this again for chloromethane, we will get about 43.57. Now, for step 4, we're going to convert the moles of each compound into moles of chlorine atoms. So if we take dichloroethane, which is C2H4Cl2, we can see that there are 2 HCl moles present of chlorine atoms. Similarly, for CH3Cl, we could create 1. For benzene, C6H6, we already stated there is no Cl component here, so we're not going to have any. So for this next step, we are going to multiply the moles of chlorine atoms available to us by the feed mole per hour. So this will be 1819 mole per hour times 2 to give us 3638 mole per hour. And then obviously 4357 times 1 remains 4357 mole per hour. So if we sum these together, we will have just about 7995 mole per hour. So for step 5, we'll convert the moles of HCl to a mass in kilograms per hour. So all we have to do here is multiply by the weight of our HCl, which we didn't calculate, so let's just do that right here and say 1 for H plus 35.45 for Cl to give us 36.45 grams per mole. So times 36.45 grams per mole here. This would give us just about 291,561 grams per hour. And obviously if we divide back by 1,000, we would get 291.5 kilograms per hour, which would lead us over here to number 3 being the closest answer. So this problem has a few more steps than some of the others on this channel, but all it is unit conversions from kilograms per hour to moles per hour for the POHCs, then converting back to kilograms per hour to find the units for HCl. And one other quick conceptual note, although benzene in this problem doesn't supply chlorine, the H in HCl's can come from water vapor or other hydrocarbons in an incinerator's flame. So there could be chlorinated compounds without hydrogen on the exam that they give you that would still produce HCl, since there's hydrogen available during the combustion. So just something they might do to try to trick you. And that's it.